To create a compound, an atom must have 8 electrons in its outer shell. In order for compounds to be created, they have to have what's called a full outer shell. And the magic number for most atoms is 8. And the valence electrons are the electrons that are in the outer ring. The columns on the periodic table contain elements with similar characteristics, mainly the number of valence electrons. And as we look at the periodic table, we can see that whatever group it's in, we can determine how many valence electrons it has, with the exception of the transition metals. The transition metals are just strange. There's always an exception to every rule in science. But if you're in group 1, you have 1 valence electron. If you're in group 2, you have 2 valence electrons. 13, 3, 14, 4, 15, 5, 16, 6, 17, 7, and 18, 8. If you go to www.webelements.com, they will show you pictures of each electron ring of all of these elements and how they have these valence electrons in their outer ring. Okay? So when you look at the periodic table, the group numbers can tell you how many valence electrons an atom has. Now, when we form compounds, we form it one of two ways. We can either give away electrons or we can share them. The first type of compound that we're going to talk about is an ionic compound, where we give away our valence electrons. Salt, like you sprinkle on your French fries, is an ionic compound. They want to give away extra electrons in order to make some other atom happy. Okay? Sodium is found in group 1. So when we look at a picture of sodium, sodium's outer ring only has 1 electron. Chlorine is found in group 17. So sodium's outer ring has 7 valence electrons. When we're forming ionic compounds, these two atoms just want to be stable, and then they want to go on their merry way. So when sodium gives chlorine its little electron all out here by itself, chlorine now has 8 valence electrons. And so does sodium, because this outer ring right here disappears, and now it's left with only 8 in its outer ring. So now it's happy. But when you lose an electron, you're called an ion. When you gain an electron, you're called an ion. And when you become an ion, you're basically like a magnet. So these two elements are now stuck to each other because they have now created a magnet. Okay? And when they created a magnet, they then created a compound. So now they're permanently stuck to each other. Okay? The compound of salt is an ionic compound, because when sodium gave away that electron up here, it now has 11 protons and 10 electrons. So it is now a positive ion. When chlorine gained this electron, it now has 18 total electrons and 17 protons. So it has more negative particles. So now it is considered a negative ion. Okay? And you can find this in almost every compound that you see. When you lose an electron and you try to give it to somebody, you become negative, and that other person becomes positive, and you've just created a magnet. Now, ionic compounds, these magnets, can only occur when a metal and a nonmetal form a compound. Okay? And on your periodic table, there is an imaginary zigzag line, and this zigzag line runs right underneath boron and aluminum. It starts right here underneath boron and aluminum, and it stair steps between aluminum and silicon, and it comes over between germanium and arsenic, then it comes over between antimony and tellurium, and then it goes over between polonium and astatine. Okay? And what it does is it separates all of these elements over here are nonmetals, and the whole rest of the periodic table is a metal. Okay? And then you may have learned that the elements that are on the little stair step, the zigzag line, are called metalloids. Okay? So an ionic compound only occurs between a metal and a nonmetal. Sodium is found in group 1, so it's a metal. Chlorine is found in group 17, so it's a nonmetal. Now, we can form compounds with just nonmetals. We can't form compounds with just metals. But you can form compounds with nonmetals. And instead of wanting to give up and becoming a magnet, these atoms want to create compounds and they want to share. So if we look at how we create water, hydrogen has only 1 electron total. Oxygen has 6 electrons in its outer ring. It has 8 total. It has 6 in its outer ring. So hydrogen is going to come over here, and hydrogen is going to help oxygen out. But when he does that, oxygen only has 7 electrons. It doesn't have 8. So we need to find another hydrogen atom. And when we find that second hydrogen atom, and they come and they share with oxygen, now oxygen has 8 electrons in its outer ring. Okay? And hydrogen, because hydrogen only has 1 ring, our inside ring holds at most 2 electrons. So now he has his electrons and he has 1 electron from oxygen. This hydrogen has his electron and 1 electron from oxygen. So now they are all very, very happy because they have complete outer shells and they're not lonely.